The subject of deposit and varnish formation in turbine oils is not new, and as the design and operational characteristics of turbines evolve to increasingly critical levels, they face increasing levels of stress, which can lead to the outcome beginning of varnish formation earlier than expected. So, this is a problem that we have to be aware of nowadays. Several factors have already been identified as inducers for varnish formation in turbine oils. Recent studies have already revealed that oil poisoning is usually the result of a complex chain of events. To start this chain of events, the oil molecules, they must be broken. The mechanisms responsible for breaking down oil molecules, they fall into these general categories: chemical, mechanical and thermal. Perhaps the main reason, as we have already discussed, be the temperature of degradation and oxidation of oils by heat dissipated due to superheated steam in a steam turbine, or the combustion of gases in a gas turbine, for example. Hello, welcome to the VIP class. I'm Ronaldo Peaks. Are you in the video series on the topic of varnish in turbines? Check out the other videos in this series. I'll leave the link in the description and the video here on the card for those who are watching it here on YouTube. If you're not watching it on YouTube, consider subscribing to our channel to continue receiving content like this. If you are interested in receiving exclusive and targeted material about services and solutions to treat or prevent problems associated with varnish on your turbine, register at this link that is appearing for those who are here on YouTube or here on the card, and for anyone watching this video elsewhere. Like all other chemical reactions, the rate of oil oxidation is limited by an already studied and known rule that states that for every increase of 10 degrees, the operating temperature above 60 degrees, oil oxidation rate doubles in typical all-turbine application steam, and it is quite common to find average bearing temperatures up to 100 degrees and average oil temperatures, lubricants at around 80 degrees, and the conventional mineral oil, such as is known, applied in steam turbines as a VG32, a 46 or 1008 itself, it will start to oxidize quickly at temperatures above 82 degrees. High-quality antioxidants, they can delay thermal oxidation a little, but then we already understand the reason for the turbines be prone to the formation of varnish. This undesirable effect, whether due to the presence of steam, humidity and high temperature in the system, that's how we just saw. Degradation can also occur by the compression of entrained air bubbles in the oil system and electrostatic discharge, leading to hotspots located in the oil, therefore favoring its decomposition. As we have already said, the varnish is mainly composed of organic residues and is not easily removed with mechanical or chemical cleaning. It is most commonly defined and identified by appearance due to its intensity and color, which can be brown, reddish or even black, depending on the original factor or other nicknames. They're even golden color. But its coloring has much more to do with an adequate description of the varnish in its final state of life. In this sense, we must expand understanding and take into account the remainder of the varnish cycle. Therefore, we must keep in mind that varnish, it begins its life as a soluble degradation product before actually converting into a particular insoluble form. And here comes a crucial point about varnish on turbines, the process responsible for the deposition of particulate varnish. It is reversible. This statement reveals that the varnish, it may be insoluble in articulated form or more dissolved, but soluble in the fluid. An understanding of lubricant solvency properties is, without a doubt, the key to understanding the mechanism by which varnish deposits are formed and, most importantly, the mechanism by which they can be removed from the oil. In response to this, some equipment manufacturers developed lubricant specifications and practices stricter oil quality monitoring. And then we can mention some sources about recommendations: high-performance oil made by some steam turbine and gas turbine manufacturers. The industry continues to develop testing procedures that better simulate the propensity of an oil to form varnishes in service. There are several papers and technical bulletins on these topics have already been published in this regard. Jeff Power herself, for example, has already declared that nothing less than 33% of the total installed fleet of Model F turbines shows some sign of oil varnish. American oil manufacturer Phillips Half-Sock, she has already published research that shows that 40% of industrial facilities reported varnish problems within 6 years of oil life. On the other hand, 81% of lubrication professionals have already faced problems caused by oil degradation products, such as varnish and oxidation. This may makes it clear that the recurrence and the importance of us addressing this issue in question. About the formation and treatment of varnish in Cuba. Did you like this content? Does it leave an unpleasant liquid? Share this video, subscribe to the channel. If they haven't been written yet, take a look at this other video, in case you missed it. Thank you for listening. Patience, company. I wait for you in the next video. A hug. I went.